When designing the behavior of a robot, you of course need a way to program this behavior. Robot Operating System, or ROS, is one of the most used frameworks to do this. After kicking off in academia, ROS is more and more being used in industry and becoming a standard for robotic applications. In this video, I will explain the basic working of ROS, also known as the computation graph. Imagine you want to program your robot. You will probably pick a programming language like C++, Python or Java and start coding by trying to get sensor data and controlling the actuators. One problem you might run into is that the thinking step might take too long. The sensor data might already be updated with really important changes in the environment. But since your program is still processing the old data, it might react too late. When talking about robots, we often use a sense, think, act loop, which looks sequential. But sense, think, then act. But actual robots, of course, need to constantly update for the changing environment. This is why the loop is actually parallel. By making this parallel, the robot can now process data while still being able to handle new data and react to really important updates. This is called multi-threaded programming. So suppose we are now programming our behavior in C++ and do this in a multi-threaded way. We will probably still run into another issue. Most sensors and actuators come with an API, Application Programming Interface, or SDK, Software Development Kit, in order to communicate with the hardware. This interface might not be accessible in the language you are using. We therefore are not able to communicate with it. That's why we need to make this setup more modular without losing the multi-threaded ability. By adding modules, each having their own responsibility, we can now program one part in, for example, Java to communicate to a camera, and another module in C++ to communicate to a servo. In ROS, we call these modules packages. This setup also has another advantage. With each module having its own responsibility, we can reuse this in other robots. There might be other robots also using this camera, so we do not need to reinvent the wheel to get things to work. By making these packages open source, we can even share with other roboticists around the world and build on each other's work. Now that we know that we need a modular, multi-threaded system, the question is how? This is where ROS nodes come in. Each package has one or more nodes, which are just standalone processes running on your computer. With ROS, this mostly means a computer running Ubuntu Linux, but it can also be run on other Linux distributions or even macOS or Windows. There might be nodes reading out sensor data, nodes for decision making, and nodes for communicating with actuators. Although it might seem that we lost the multi-threaded part here, the operating itself will now take care of this. It will make sure that each process or node runs as its own thread and does the scheduling of the task on the CPU. We still have one open question though. How do we get the data from one process to another? Usually, two processors on a computer are not able to communicate with each other. To do this, we need inter-process communication, or IPC. This is where the ROS API comes in. ROS1 uses TCP messages, also used in the internet to communicate between the computers, to communicate between nodes. ROS2 uses DDS, which has multiple ways of communicating between the nodes. In ROS, there are three ways of how to communicate. But let's first have a look on what to communicate. In a lot of programming languages, you need to specify the type of your data so the computer knows what to do with it. For example, integers, doubles, strings, etc. Note that Python is trying to be smart and guess the type based on what you type. This might mess up things though. In order to make sure that nodes are expecting the same data in the same format, we need to define this. These are called message types in ROS. Apart from the basic types, there are already a lot of predefined messages often used in robotics. Think of a data format for laser scan data, but also a format to send a velocity message to the motors. It's really important for your own nodes to adhere to these standards. Otherwise, your nodes will not be able to communicate with others. Now that we defined the type of the data, let's have a look at the 3 ways to transport this data from one node to another. This first one is called topics. A topic uses a publisher-subscriber mechanism to communicate some data. Imagine a node that is translating the LiDAR data from a C++ SDK into standard ROS LiDAR data format. In a previous slide, we discussed the data type. But programming language also needs a variable name for your data. This is how the program knows what data to access. This also holds for topics and is called the topic name. For example, left_LiDAR. The C++ node now publishes this sensor data to each node that is subscribed to this topic name. Note that this might be more than one. This data stream is mostly used in sensors publishing their data. This is done in a unidirectional way so that data only goes one way, from one node to the other. You can imagine that it might also be useful to have bidirectional communication between nodes. These are called services. With these services, you can actually call a function in another process and wait for its return function. The downside is that this is blocking. So as long as a node serving the service is still processing, the client node is not able to do anything else. You therefore should only use this when you know the server node will not take too much processing power. But it might of course be useful to have non-blocking bidirectional communication as well. This is where actions come in. You can imagine that you want to move your robot to a certain position while still being able to perform other tasks. The action can be used to execute a long-running process while the client is still able to do other things. So why not always use actions for everything? Theoretically you can, but actions are harder to implement, making your code more complex. More complex code usually leads to more bugs. So let's recap the 3 ways to communicate between ROS nodes. Topics are mostly used for data streams, actions for long-lasting actions, and services for short communication between nodes. With this, I hope you got a basic understanding of ROS and how ROS is able to both be modular and multi-threaded.